Good morning to our lecturer, Encik Mazlan. Okay. We are from group 1/1 #2, and we are going to present for this lab 1. So I'm Yongzhan Hu.
I'm Chong Jin Yang. Ilya.
Oh, Ilya Amira Akila.
My name is Muhammad Rasyukri bin Abdul Halim.
So by referring to this lab sheet, okay, we are going to design a system, okay, which consists of ASRS stations, milling stations, lead station, vision sensor station, and also the last station, PX5 for inspection stations, or we call as counting stations. Okay, so by referring to this lab sheet, okay, there's only 10 conveying medias, and the automatic ASRS is only have 20 storage, which is 10 for the empty jig and a 10 for the complete jig. So we'll be going to present on this PLC. So, okay, at this PLC, we have split the task, okay, which is a station, ASRS station will be presented by Shuk, milling machine by me, Leong, and leg machine by Ilya, and vision and last station 5 will be by Chong, okay. And then we also interpret the main control station, so user can view the condition of the system. Okay. Okay, so now the system is at standby light, so now we start the system by pressing the start button, and then okay, the system is running, and yeah, the conveyor will be running too till we stop the system. Okay, so for this ASRS station, I will pass to Shuk to present.
So for the for the ASRS station is to store the jig on the force safe, and to the top of the two shaft is used to put the empty jig, while the bottom of the two shaft is used to put the complete jig. So we use a few input and output signal to control the station, which is PX1, inductive permittive sensor, ID1 sensor to sense the ID tag of each jig. Then for the robot to place the jig, so we use these three output signal, which is output load signal, output unload signal, and input of return signal. So for the load signal, the PLC will give a short pass to the robot with this load signal. So the robot will take the jig from the conveyor and place on the bottom of the two shaft. So
Yeah.
So for the unload
Signal. Okay,
so for the unload signal, the PLC will give a short path to the robot, same as a load signal. So then the robot will take the empty jig from the bottom of the two shaft and place on the empty pallet of the conveyor.
yeah, the short pulse actually because we use a differential up command, so it will be only a short pulse.
Yes. So the unload signal will be count to 10 times only, and we use only 10 jig to the process. So in the same time, we'll realize that the complete jig that reach the station will take the jig and place on the shelf. So this station have two position. So when the PX1 detect the pallet,
Okay, so when PS1 detect the pellets,
it will give 1 second for the ID sensor to detect. So If no ID is detected, the PLC will send to the unload signal to the robot. After the robot finish the process, the robot will send a return signal
Yeah.
to
Okay.
the PLC, and then the stopper will power to retract so the pellet can pass now. After the pellet pass, the PX1 will give no signal, and then the section will reset, which
Okay.
the stopper will not power up, and the stopper will extend to all the following pellet. So for the second condition, when the
Okay.
PX1 detect the pellet and the ID1 detect the RFID tag, the PLC will send the loaded signal to the robot. So it will take the jig and place it back to the bottom of the shelf. So after that, so the robot will return the signal to the PLC, and then PLC will check whether it's reached the count of 10.
Okay.
So if not reached the number, PLC will send the unloaded signal.
And then last is a return signal.
To return. So after the robot return signal to the PLC will then power will stop, and the stopper will retract and let the pellet to pass.
So after pellet pass, PX1 no signal.
The PS1 ID1 will get no signal, and session will reset. So the stopper will not power up.
Okay, so this is for this ASRS station. Okay, so now we go to milling station, okay, so for this milling station, we have PX2 and ID2. Okay, after that, we have the start milling process output and also finish milling process input that come from the robot. Okay, so and last we have the milling station stopper. So as usual, okay, this PX2 when it detects the pellets and the ID is not correct, it will let the pellet to pass because we have the unique number of the ID for each jig. So if the jig is not required milling process, it will bypass for these stations. And then when the PX2 is not detected the pellets, okay, then the stopper will then not power up and extend. So it will be stop the following pellets. Okay, so for second condition, when the PX2 is detected and at the same time the ID2 is detected that this jig is required for this milling station. Okay, so it will send the start milling process to the robot controller. Okay, therefore, after the robot finish, the robot shall send a finish milling signal to this PLC, so it can be continued for the process. So when it receives the finish milling signal, okay, which means that the robot is placed the complete process material on the jig and on the pellets that on the conveyor. Okay, so the stopper will then energize and power up, so it will retract, so let the pellet pass through. So when the pellet is passed, so the ID2 will not be getting any signal, and yet the PX2 will get no signal too. Okay. Wait. Okay. So this is for these milling stations. So now for the late station, we will pass to Ilya for the explanations.
So I will explain about the lead station. So for this lead station, it is actually similar to the previous milling station. It will process the raw material, and then a robot arm will help to place the completed process material from the lead machine onto the jig that locate on the conveyor. It will be 3 input, which is PS3 proximity inductive sensor, ID3 detect jig ID tag, and lead machine finish signal. Then 2 output signal, which is start lead process signal and stopper signal. We will assume with three conditions. First condition is the pallet is come with G, which is not for lead station. It will have a delay for 1 second to let the ID3 to check. It results the G is not for the lead process. The stopper will be energized and will retract and the pallet will pass. So after the pallet pass, the PS1 will get no signal and then the process will be reset. To the
With PX3, yeah. Yeah, PX3.
yeah. So to the second condition, when the ID3 detect the G is for the lead process that come with ID, PS3 detect and ID3 detect. It will give a signal to the start lead process. After lead process finish, it will return to a signal to PLC. When the finish signal is received, the stopper will be energized and let the pallet pass. So after the pallet pass, the PS1 will get no signal and the process will be reset.
Okay, so that's all for the late station. Okay, so now we are going to the fourth station, which is vision station, and this will be presented by Chong.
Okay, in this vision station, as a final inspection of material, we assume that all vision check is success. So we got PX4 and ID4. When both signal is detected, we send a vision enabled signal to trigger with vision successful signal. And stopper will power up and will retract to let the pallet pass this station.
Yeah, when
So
PS4 and ID4 is
yeah,
not detected. Okay. So actually, this vision enable signal is also same. We use a differential up, so just give a short pulse signal.
yeah, when no signal get to initial condition, just like. So next station. So go to this station. It's a vision inspection station. So just count 10 times to complete the process, which the PX5 will detect the zig on the pallet. So count 10 times. And after counting, it send a successful signal to the main control station.
Okay, so that's all for this 5 station. Okay, so back to this main control station. After the process is finished, okay, the user actually need to press the reset button to reset all the system. So after pressing this reset button, okay, at the ASRS station, the counting will be reset back to 10, and also for the inspection will be reset back to 10. And then yet the system will back to standby lights, so it can be restart again. So that's all for the presentation of Lab 1 from our group. Thank you, sir.
Thank you, sir.